When you read iot-64 assembly code, you will constantly see branches, labels, and function calls. But how does the processor actually decide where to go next, and how does it safely return after calling a function? In this video, we will explore how branching works in iot-64 and how functions use the link register and the stack to stay organized. Branching is how a processor controls program flow. A branch instruction tells the CPU to jump to another location in the code, identified by a label. Some branches are unconditional, they always jump. Others are conditional and depend on status flags stored in the processor's status register. These flags include 0, negative, carry, and overflow. They are set by instructions like CMP or subs. When a conditional branch is executed, the processor checks these flags to decide whether the jump should happen. For example, after comparing register with 0, the BEQ instruction will branch only if the 0 flag is set. This allows the program to repeat loops, skip instructions, or choose different execution paths based on comparisons. iot-64 also provides combined instructions like compare and branch or test and branch, which makes quick decisions even more efficient. To call a function, iot-64 uses the BL instruction, branch with link. This instruction does two things at once. First, it jumps to the function's label. Second, it saves the return address in the link register, also known as register x30. This stored address tells the processor exactly where to continue once the function finishes. Most functions begin by creating a stack frame. This is done in the function prologue, where the current frame pointer and the link register are pushed onto the stack. The stack grows downward in memory and must always remain 16-byte aligned. Saving these values ensures the function can safely call other functions without losing its return address. When the function completes its task, the epilogue restores the saved registers from the stack. The ret instruction then uses the link register to return execution back to the original caller. This clean entry and exit structure keeps the function calls predictable and reliable. In summary, branching controls where your program flows. The link register remembers where the return, and the stack preserves important state across function calls. Together, these mechanisms form the foundation of structured programming in iot-64.